Hey there, everybody. Welcome back. We're going to do our next set of notes for Pre-Calculus 11. This is the second set of notes for Unit 2. Really, we're just going to do a continuation of what we started in the last video, which is taking a look at how to solve quadratic equations by factoring. And we're just going to do a few examples, just a reminder of some of those special cases, because the straightforward factoring ones I think are pretty easy, but there's a few wrinkles we can throw in here and there. So let's look at this first one here. We got 4x squared minus 25 equals 0. And so to solve this, to factor this, first thing I notice is this is that special case where I've got a difference of squares here. And so I can actually write this as 2x plus 5 and 2x minus 5. And of course, that's going to equal 0. So when I solve each of these binomials, that means either 2x plus 5 equals 0. And if I move the 5 over, I get 2x equals minus 5. And if I move the 2 over, I get x equals minus 5 over 2. And then if I do the same thing with my second, so that was the first binomial, I do the same thing with the second binomial, 2x minus 5 equals 0. And so if I move that negative 5 over, I get 2x equals positive 5. And then when I move the 2 over, I get x equals 5 over 2. And so those are my two solutions for this one. I want to point out, though, there is another way to solve this, and this is maybe a little bit quicker and simpler, and it's going to help us out later on. I could, because there's no b term, because the b term is 0, I could just take this initial equation, and I could just move the 25 over to the other side. So I'm going to do that right now. So move 25 over to the other side and get 4x squared equals positive 25. And then I could move the 4 over to the other side, and I would get x squared equals 25 over 4. And then to get rid of the square here, I would have to take the square root of both sides, and so I would get x is equal to the square root of 25 is 5, and the square root of 4 is 2, so 5 over 2. Now, at first glance, this looks like, wait a second, what happened to that other answer? And what I want you to remember is that whenever you take the square root of something, the answer is actually going to be plus or minus, because the square root of 4, for example, is not just 2, it could be 2 or it could be negative 2. Both of those squared would give me 4. So my answer here is plus or minus 5 halves, and you can see this really is the same thing that we got before. Okay, let's do the next problem. So in this case here, I got 3x squared minus 30x plus 72. If I wanted to factor that, my a value there isn't 1, and so I might be tempted to try and do decomposition or something else. But if you look closely here, you'll see that actually there is something we can factor out. We can factor out 3 out of all of this. And so I could take a 3 out there, and I would get x squared minus 10x, and then plus, this should be 24. 72 divided by 3 is 24. And that whole thing is going to equal 0. Now, the point I want to make here is when I get to this point, and I can factor this further, but right here, when I've got this factor of 3 out front, notice that I've got a 0 on the other side of my equation. Whenever that's the case, I might just go ahead. I'm just going to divide this whole side of the equation by 3, and divide this by 3. And 3 divided by 3 will just be 1, and that'll cancel out. And 0 divided by 3, well, that's still 0. So in terms of solving this, I've kind of just gotten rid of that 3. It doesn't affect my, doesn't really affect my equation. It doesn't affect my answer. Of course, if that was a function, that 3 would change what the function looks like, but it wouldn't change the roots of that function. So now I've just got x squared minus 10x plus 24 equals 0. And so I'll look for two numbers that multiply to 24, but that add up to negative 10. And the ones that occur to me are negative 6 and negative 4. And so I can factor that. X minus 6 times x minus 4 equals 0. And then so x minus 6 equals 0, which means x could equal 6. Or, that's that first binomial. Or the second binomial, x minus 4 equals 0, so x could equal 4. And so my solution is x can equal 4 or 6. 4 and 6, really. Okay, moving on. Again, one of these problems, we've seen this before, but I thought it'd be worth just doing another example of it, where it just looks like an absolute mess to start with. A reminder that all we have to do before we can start factoring is we just need to move everything over to one side of the equation, and we need to collect all the like terms. So we've got one a value, one b value, one c value in standard notation. And so I'm gonna expand through this bracket here to get 2x squared minus 6x minus 8. And then on the other side of the equation, I get negative 2x plus 44. Okay, and so I'm going to bring this 2x to the other side of the equation. I'm going to add 2x to both sides. So plus 2x, I'm going to add 2x there. I can do this all in the same step. I'm also going to subtract 44 and then subtract 44 there. And so these are going to cancel out, and I'm left with 2x squared minus 4x and then minus 52 equals 0. As I mentioned before, you can see here that I can actually factor out a factor of 2. So I'll take out that factor of 2, x squared minus 2x, and then minus 26, and that's going to equal 0. I can factor out this 2. I'm going to divide this whole thing by 2 and divide this by 2. So those are gone. And then let's see here. So I've got x squared minus 2x minus 26 equals 0. So what two numbers multiply to be negative 26 that add up to be negative 2? Well, factors of 26. So I've got 1 and 26, obviously, 2 and 13, and that's it. There are no other combinations of factors that are going to work here. So what I want to point out is this does not factor, okay? And that doesn't necessarily mean that it's broken. It just means it does not factor. But that is not the same. That is not the same as saying that there is no answer, okay? All this means is that it doesn't factor. We're going to learn later other tools that will allow us to actually solve these. Right now, we just don't have the tools to make this work. But if you were asked to factor something, it's entirely possible that it won't factor cleanly, and so we need something else in the toolbox to make that work. Okay, so we're just going to have to leave that one there for now and maybe come back to it later. All right, so let's take a look. We've got x squared over 18 plus x over 6 equals 1. And I just want to point out with this one here, this sort of looks ugly and you're already thinking about dealing with fractions and it's giving you a headache. And I just want to point out that there's a really simple way to make your life a lot easier right off the bat. And that is simply, let's just multiply this entire equation by something that's going to eliminate all of the denominators. And so what's the lowest common multiple between 18 and 6? Well, that is 18. So I'm just going to multiply both sides of the equation. I'm going to multiply everything by 18. And I can do that as long as I multiply everything by 18. So 18 is going to cancel here, and I'm just going to be left with x squared. 18x over 6. Well, 18 divided by 6 is going to be 3, so that's going to become plus 3x. And then 18 times 1 is just 18. Now I can move 18 to the other side of the equation. X squared plus 3x minus 18 equals 0. And now I can factor like I normally would. So something times something equals negative 18. Something plus something equals 3. And so that would be positive 6 and negative 3. Positive 6, negative 3. And so I get x plus 6 times x minus 3 equals 0. So set this first binomial equal to 0, x plus 6 equals 0, so x equals negative 6. Set my second binomial to 0, x minus 3 equals 0, so x equals 3. And those are my two possibilities. So x can equal negative 6 and 3. Okay, so that's it for the second part of the factoring.